Welcome everyone to this video. So today we are in for a day for lots of fun because we are going to begin uh, with the equations of differentiation. So in the last video, basically we discussed that we uh, were able to relate what is average velocity to instantaneous velocity. So to do that, we use a mathematical tool called differentiation or derivatives. We say that instantaneous velocity for a particle whose position is some x is given by dx by dt. So today we want to use that concept. We basically want to say that at some different times the particle's velocity changes with time, and because of that, we have to use this tool. So, as such, if we want to differentiate some simple terms, like we were talking about curves. So the first curve which we are going to study is this one. Let's say I have this y, that y and x curve we have drawn like this. So now if this is a constant curve like this, uh, so this is a line which is parallel to x-axis. So if you can recall what differentiation did, differentiation basically said that we are finding the slope of the tangent. So as we are finding slope of tangent at different points, we can say what is the slope of tangent at this point. We can say what is the slope of tangent at this point, right? So slope of tangent at this point and this point. Wouldn't that tangent be this line only? So the slope of this line is zero because it has no inclination whatsoever. So that means that if y is a constant, then dy by dx is zero. So this is what differentiation means. Differentiation means finding the slope of tangent. So if it is same at all points, it will represent some number. If that slope is zero, it becomes zero. So this is one of the first cases which we discussed. Now instead of uh, having y as some constant, let us take y equal to x. So y is equal to x. How would this curve look like? This curve will look like this. So uh, if x is equal to 1, we know y would be equal to 1, right? Because if we put the value of x as 1, y will become 1. So, like in the previous video, we did the ratio of perpendicular with the base to find the slope of the tangent. In the same way, if I take x equal to 1 here and y is equal to 1 here, x equal to 2 here, and y equal to 2 here. So at these two instants, that is x equal to 1 and x equal to 2, y is 1 and small is 2. So here, if I take the ratio, here the ratio uh, y by x is simply 1. Here the hypotenuse, the perpendicular is 1 and the base is 1. Here the perpendicular is 2 and the base is 2. So 2 upon 2 is also 1. So that means that the ratio of the slopes at different points is always 1. So that means differentiation of y with respect to x is 1 in this case. So this is also what we have done. Okay, now let's move on to some more general cases. Now, let us take a case when y is equal to x squared. So, what is this kind of curve? This is a parabola. Parabola is a special curve where if I put the value of x here as let's say plus 1, its value is going to be 1 square. But if I put, let's say in the same way, I'm putting x equal to minus 1, the value comes out to be same only. So this kind of curve where the whatever value I'm putting, it is basically outputting some positive value. They are restricted to some definite coordinates in the rectangular coordinate system. So if I were to draw like this, the curve would look something like this. So this is a parabola. So this was the first thing to notice. Okay, here all the values of y are above x-axis, which means that they are always positive. So if they are always positive, no matter what the value of x I'm putting, y is always going to be above the origin. Okay. Now, what about the slope of the tangent? So the slope of tangent at this point can be obtained by drawing a tangent like this. Let's say a tangent I draw like this. Again, somewhere here, if I take a tangent. So these are two distinct points. Point number one, I hope it is visible. This first point here, some tangent is drawn, some line which is close to a tangent. So this is a line which is tangent, and this is also a tangent. So these two tangents are having different slopes. So as they are having different slopes, what does it mean? It means that they will have different values of dy by dx. So that means that when I put the value of dy by dx, or I determine the value of dy by dx, it must vary with some quantity. So for now, we are not going into details how we obtain dy by dx, but we can just write an equation that what it is. So we'll say y equal to x square. If this is the equation, then its derivative is 2x. So this we can also check. What if the value of x is 0? So if the value of x is 0, the slope would be somewhat like this because the tangent is drawn here at x equal to 0. So as you can see, this graph is always along x-axis or parallel to x-axis. So the slope is 0. So this value should also come out to be 0. If I put the value of x equal to 0 here, it is coming out to be 0. So that means differentiating y with x square with respect to x, it gives us dy by dx equal to 2x. Okay. Now we want to write some different equations. We want to write about x square. X square we have already written. We want to write about x to the power n. So what about curves like this? If there is a curve y x to the power n. So this is the curve. So now n can be any value. N can be 1, it can be 2, it can be minus 1, it can be minus 2 as well. So what to do? In this case, we remember that dy by dx is equal to n x to the power n minus 1. So here you have to remember how we differentiate. Differentiating such a term y equal to x to the power n, or calculating dy by dx when y is equal to x to the power n, then whatever power I have, that is n. This is n. Okay. I hope that is clear. So this is n and this is x. X is the variable and n is some constant number. It could be 1, 2, 3, something like that. So this n, it comes as the coefficient. It comes to the coefficient of whatever thing which we are having, and that thing, that is x, its power will reduce by 1. So here, like you can see, n came to the side, it came in the coefficient, and my power n, it became minus 1. So this is what differentiation of y with respect to x is when y is equal to x to the power n. So I'll demonstrate it once more. Like we did the differentiation of y is equal to x square. When we differentiate y is equal to x square, 2 came to the side. That is in the coefficient. And my power, it subtracted by 1 or it reduced by 1. So it became 2 minus 1, that is 1 only. So it became 2x. Similarly, if if y is equal to mm, x cube, I am taking. So now if I differentiate, now power 3, it came to the side, and whatever power I had 3, it reduced by 1. So this became dy by dx is equal to, so it became square. So it is 3x square. So this is my dy by dx when y is equal to x cube. So I hope that is clear okay, what we are doing here. We are basically calculating the derivative of y with respect to x, which has different names. It is also called the differentiation of y with respect to x. It is also called dy by dx. It is also called dx or dy, which like I told yesterday in the previous uh, video. So these are some standard differentiations which we encounter in kinematics on a regular basis. Okay. What about trigonometric functions? So y is equal to sine x. So this is a pretty common theme which we'll encounter, some sine x. So now we have been encountering trigonometric functions where this x has been, where the angle is some theta, right? Theta or phi or alpha or beta, but never x. But it's just a variable, right? So we can take it as x. It's up to us. If I were to take theta, so I would have to differentiate with respect to theta. But here we have taken x. So if we differentiate with respect to x, I'll write something like this, dy by dx. So now I'll have to know what is differentiation of sine x. So differentiation of sine x is cos x. So again, we do not know, okay, how we came about differentiation of x square and differentiation of x to the power n. But its usage is what we have to focus on. We'll have to use these equations and these uh, terms when we are calculating instantaneous velocity. So because of that, we have to know, okay, when we differentiate some position of the particle with respect to time, then what is the instantaneous velocity? So only for that purpose we are doing differentiation. And that is why we are focusing on what comes out of differentiation and what is its meaning rather than how it is being done behind the scenes. So let us take one more idea. So the one more idea which we are going to learn today is a chain rule. So let's first write. Chain rule is a very useful tool to differentiate multiple terms when we have two or more terms clubbed together in a single term. By that I mean is that, let's say if I have a term like y is equal to x sine x, something like that, if I have to differentiate. Or we can take y is equal to sine ax. Pretty interesting thing. We just learned what is y is equal to sine x differentiation. It was cos x. And because we know sine and cos are complementary functions, it is pretty easy to remember. But what if I put a simple constant like a inside this? How can we do uh, now? So the answer is pretty easy. Chain rule tells us that when we differentiate a term like this, we have a outside inside uh, going principle. In this case, like this, we have when multiplied x with sine x. In this case, maybe chain rule we can apply. But in this case, when y is equal to sine ax is there, here, first we will see that what is the term inside the whole thing. That is ax. And then we see that what is it enclosed by. So it is enclosed by sine. So sine ax, first we say what is the outside inside rule, right? So when we're going from outside to the inside, first thing which we see is sine. So first we'll differentiate that. Let me write. Let's say I want to write what is dy by dx for this term, y, right? So as I'm differentiating y is equal to sine ax, and I have told chain rule is the outside inside rule. So when I'm going from outside to inside, the first term which I see is sine. So what is the differentiation of sine? Cos, right? And the term within sine would remain as is. After that, we'll cancel sine out like this. Sine we have cancelled. So that means we are done with differentiation of sine. Sine has been differentiated to cos, and ax terms comes as is. Okay. Now I have to differentiate ax as well. So we know if there is a term, constant term a, and it is multiplied with the variable x, then that constant simply comes outside of the whole term. So as it is coming outside like this, we have taken it outside, and differentiation of x is 1 only. So this is what is differentiation of sine ax. This value comes out to be a cos ax. What about this x sin x if I have to differentiate? So x sin x we differentiate using multiplication rule. Multiplication rule is pretty simple to understand. What we do is that if I have two terms u into v, something like that, okay, I have to differentiate them. So what we do is that we first differentiate u, differentiating u first and keeping v as is. So if I differentiate u, I get du by dx. I'll keep v as is. Now I'll add a put a plus sign like this plus. Now v has to be differentiated dv by dx and u as is. So differentiation of x sin x what does it lead? That is d by dx of x sin x. We'll differentiate x first and let sin x be as is. So differentiation of x, as we just saw, was 1 only. Differentiation of y is equal to x leads to 1, and sin x will remain as is. Then x as is, putting the plus sign, x as is, and differentiation of sin x, which is cos x. So this is differentiation of x sin x using product rule. So thank you for joining and have a good day.